Okay, Assalamu alaikum. This is the study guide quiz solved. Let's start with the first question, which is use figure to find each of the following questions. And this is the figure basically. So here they ask us what is the limit of f of x when x tends to 2, positive 2 from the negative side. So what is positive 2? This is positive 2. We have to mark it here. Let's make it with a more clear color, like blue. Okay. So from the positive side, we see that this function right here, the semi-like parabola, is approaching 2 from the positive side. And it has a functional value of 2. Okay, so we will write that limit x tends to positive 2 from the negative side. So we see it's from the negative side leading to 2 is equal to f of x equals to 2 or positive 2. Here the same thing, just from the positive side they want. So where's the positive side? This is the positive side we see. Okay, and we see that this function, the tangent line, is approaching to 2 right here from the positive side, and it has a functional value of 4. So same thing, we write limit x tends to 2 from the positive side of f of x equals 4, or positive 4. Here, they didn't give us whether it's positive or negative side, so we will do both. So they want negative 2. This time we will remove these. Let's mark negative 2 here. And we see that from, let's start with the negative side. So lim x tends to 2 from the negative side. We see that this function is tending to 2 from the negative side, and it has a functional value of 2. So f of x equals to 2. And for limit x tends to negative 2, so here negative 2, from the positive side, we see that this semi-like parabola from the positive side is tending to negative 2 at 4. So f of x equals positive 4. And here in this case, they're asking us, so this is how it looks like in the original. So when we replace x by negative 2, so we go to negative 2, what is the functional value? See here, they didn't give us limit. They asked us about the functional value. And the function we have to know is the whole one. So if it's hollow, this is limit. And if it's not hollow and filled, it's function. So at 2, where is the whole? It's at 4, we see. So not 2 because it's not filled, but 4. So we will write here f of x, or f of negative 2 equals 4. So this is for the first question. The second question asks us, find the equation of the tangent line to the function at a given point. First of all, what is the equation of the tangent line? The equation of the tangent line in this case is going to equal to y equal to mx plus b. It's a linear line, it will be, because we have here x squared. So the first thing we will do is basically, let us just write here the equation. Step 1, the equation, which is y equals mx plus b. Step 2 will be getting the derivative of it. Why? Because that's how we get the tangent line at m. So what is m? What does it resemble? M resembles slope, or as we call it in calculus, derivative. Okay, so we'll have to find the derivative of this equation of 10x squared in order to find m, and then we'll find b via finding y. So we'll leave that for the third step. So for the second step, we will get m, and in this case it will be f of x, or f of prime of x equals, now to get the derivative of this equation, which is 10x squared, we'll put 2 in the front or in the back, so it becomes 2 times 10 x, and then minus 1 from the 2, so it becomes x power 1, which is the same as nothing, so we'll just leave it as x. So this becomes f prime of x is equal to 20x, And if we sub in the value of x, we know it as 2, it becomes that f prime of x is equal to 40. This is the derivative, or as we know before, the slope. So m is equal to 40. So now if you write the equation once more, it is mx plus b. Then let's replace m with 40, so it becomes 40x plus b. Now let us replace x with 2 again, because that's the value of x. They gave us that at the point of x equals 2, we will get the equation of the tangent line. So we will write 40 times 2, then plus b, which is the same as y equals 80 plus b. Now we need to get the value of y in order to find b. How will we do that? We will just sub in, so let's just put this down a little bit. So we will just, to find y, this is the value of y, basically, and they gave us a value for x. So we will write here 10 times 2 to the power of 2. So the difference between this step and the first step was, the first step we had to get the derivative, then sub in for value of x, but this time we will sub in the value of x right away in order to find y. So 2 power 2 will be 4, times 10 will be 40, so y is equal to 40. And now if we write the formula again, it becomes 40 equals 80 plus b. Now to find b, we'll just put 80 to the other side, becomes negative 40 equals b here. So now we have everything. We have y, which is constant, we have m and b. So it becomes, our equation of the tangent line is y equals 40x minus 40. This is the answer. Okay, so let's just take this and put it up somewhere. Okay, now this is where we have to focus a little bit, because we have the difference quotient or quotient rule. So they gave us this formula. They want us to find the derivative of this equation, which is 1 over x squared. In order to find the derivative of this equation, we must first solve it by the power rule and then confirm it using the difference quotient rule. So first of all, what is the power rule? To remember real quick, the rule is that if we have y equals m to the power of x, then we'll put x backwards, so it becomes y equals x times n, and then we'll minus 1 from the power, so it becomes x minus 1. And this is basically the power rule, just to sum it up real quick. So, as we said, we need this rule to be put in this form, which is y equals n to the power of x. And in this case, it's a division, it's in a fraction, it's not the same. So what we will do is that we will flip the fraction and then flip the sign of the power. So it becomes what? It becomes x squared, the same thing, but since we flipped it, then it becomes negative 2 instead of positive 2. So this is how it should look like. Now we can get the derivative using the power rule. So now we will put negative 2 backwards, so it becomes negative 2 times x, and then minus 2 minus 1 becomes minus 3 and not minus 1. Some students may make a mistake. So it is minus 3. Again, we can do the same step as the first step here, which is to write negative 2 times x power negative 3 is basically the same as 1 over x power positive 3. And then negative 2 times 1 is the same thing, so it becomes negative 2. And finally, this is our answer, which is negative 2 over x cubed. And this, our answer should look like after we solve the, okay, let's put it up here. After we solve this equation using the difference quotient rule. Now, we will start with the difference quotient rule, arguably the hardest skill in this test. And yeah, so if we start with writing the equation or the formula of the difference quotient rule, we must write first limit of h tends to 0. Now we write f of x plus h minus f of x over h. This is what the rule looks like. Now, we must know two things. First of all, what is f of x equal to? And what is f of x plus h should look like? If we go here and just we write what the 2 should look like. So for f of x, we already know that f of x is equal to 1 over x squared. So 1 over x squared. Now for f of x plus h, we will do nothing but to remove the x, and we will put x plus h in it. So we will just duplicate this formula, the same exact formula or equation, and we will just remove the x and put x plus h instead. So it becomes here, to make it clear, x plus h power 2 or whole square. Now, we can just sub in these values in our equation. So f of x plus h, here we can remove it to what? Or let's just write a new step. Here, duplicate. It becomes, okay, so here let's just duplicate it 1 over x plus h whole square minus f of x is here, we already have it, f of x is equal to 1 over x squared over h, the same thing. We didn't change anything with h. Pardon me. So now what happens is we will cross multiply. So with x plus h squared and x squared, we will multiply these two. So it becomes, here, it becomes limit h tends to 0. Here we will have x squared times 1 is x squared. So just like, let's write it as x squared. And x plus h whole squared times 1 is the same thing. So minus x plus h squared, our whole square. And since we will multiply these, the denominators together to make them common and be able to use the subtraction in fractions, we will write them in the denominator. Why? Because if we have a over b over c, it's the same as a over b times c. So we have here a denominator over denominator. Hence, we will write it as this x squared times x plus h whole squared times h, the same thing, we didn't change anything with it. And now we will write, we will expand x plus h squared or whole square. So this becomes limit h tends to 0, x squared minus x squared. So basically a plus b whole square is equal to a squared plus 2ab plus b squared. This is the rule to refresh the mind real quick. So it becomes plus 2xh plus h squared, okay? Over x squared, we won't change anything in the denominator. So it becomes x over, x squared times x plus h whole square times h. We will not expand the x plus h in the denominator because it's not important further more in the solving steps. So now our step will be to times the negative on each of the terms. So we can just duplicate this equation and it becomes, duplicate here. So if we put it up here and then, okay, just a little bit down. We don't need this anymore. So this becomes x squared minus x squared minus 2xh minus h squared. Okay, so we didn't do anything, we just changed the sign of each terms in this equation or polynomial. So now we can just cancel x squared with x squared or minus x squared. So it becomes here our equation as limit h tends to 0 is equal to minus 2xh minus h squared over x squared times x plus h whole square times h. And in this case, we have this h that we can cancel out with the h squared here and the h in minus 2x times h. So our equation becomes limit h tends to 0 minus 2x minus h over x squared times x plus h whole square. Now, and finally, now we can sub in the value of h as 0. So here in this case, if we sub in h as 0, it will be the same thing, so it's not important. It becomes x squared here, x squared times x squared in the bottom, and 2x minus h is 0, so again it does not matter. We can just cancel it. So our equation becomes something along the lines of limit h tends to 0 minus 2x over x squared times x squared, which becomes 2 or negative 2x over x to the power of 4. And then we can cancel 1x of the 4 with the x in the numerator. Hence, our final equation becomes negative 2 over x squared. And if we compare this answer with our first answer using the power rule, if we go up, see the same exact numbers. So negative 2, x cubed, same thing. Now we solve this question B from question 2. We can start actually with some easier questions. So if double derivative is negative on an interval, then f derivative is, so this means that it is decreasing because it's going to the negative interval, and f will be what concaving down. So why concaving down? So if double derivative is on a positive, not negative, positive interval, then it will be concaving up. You see, positive values. But if it was double derivative on the negative intervals, then it will be concaving down, we see. Okay, so yeah, it will be concave down. Okay, here, if a function is differentiable, then it is continuous, and if a function is not continuous, then it is not differentiable. Let us remember and refresh what are the rules of if an equation is differentiable. Or differentiable means you can go through the derivative steps without getting d and e, which is the same as value not found. So it becomes, our first rule is no tangent lines. Tangent lines. What do they mean by this? Vertical asymptotes. Okay, this is the first rule. Second rule, no sharp corners. And finally, third rule will be it should be continuous. Should be continuous. Okay, so if any of these conditions were met, so all of these conditions should be met in order for the function to be differentiable. Okay, so let's go to the first question in true or false. If a function is differentiable, hence it meets all of the requirements, so it has no tangent lines, it has no sharp corners, it is continuous, then what does it say? Then it is continuous, and it is correct because it is differentiable. So true. And then if we go to the second question, if a function is not continuous, so one of the steps is missing. Maybe sharp corners, maybe continuous, maybe vertical. So then it is not differentiable, which is true. So if we say that the function is discontinuous, hence the third step is not met. So maybe the first and second step is met, but the third step is not met. So it means that it is not differentiable, which is again true. If you go down here, sketch the graph. So sketch, we don't have to be very specific. Sketch the graph of f of the derivative of x on the same graph for a and b. Okay, no problem. We see that the slope of this graph is 1, and we can just draw the horizontal line because here, if it's a parabola, then the derivative of it will be a linear line, and the derivative of that would be a horizontal line. So the slope will be of this, the derivative or slope as we learned here above, is that the slope is the same as derivative. But derivative is the term we use in calculus. So the slope is -1 and it should be horizontal line, so it should look like something like this. And for this one, so we'll go from the stomach of the parabola, And we know that if it's a parabola and it's facing down, so it's a negative function, then the derivative of this should be a negative linear line, and the derivative of that would be a horizontal line. So the derivative of that would be a negative line, and if we go here from the middle, we see that the function from the, okay, so let's divide this function in two pieces. We see that the function from this side is decreasing. It is decreasing, going down. Hence, our linear line should be decreasing from this side, okay? And from this side, we see that it is going up. It's going up, you see? It's going up. Hence, it should be increasing from this side for the linear line. And that is how our equation should look like. As you see, it's a linear line. Question C and D, Mr. told us to not worry about. C we can just remove. For to explain D, refresh the skill, we can just say that x squared, if we sub in x equals to 3, then our equation becomes 3 squared minus 9 over x squared plus x minus 12, which should give us 0 over 0, and that is undefined. It's wrong. If we get 0 over 0, then we must do a step before subbing in the value of 3, which is usually in this case factorization. So if you factorize, x squared minus 9 is the same as 3 squared over x squared plus x minus 12. We won't change anything in the denominator. It becomes, we know the rule of a squared minus b squared is the same as a plus b times a minus b, okay? So it changes to x plus 3 times x minus 3 over x squared plus x minus 12, the same thing. So I'll just remove this rule. And then we can also factorize the denominator again. So numerator will leave it the same. So x plus 3 times x minus 3. We didn't change anything. Over, we can factorize it into x plus 4 because we see that the number here is positive. So the higher value should be positive. Times x minus 3. So we see that if we time these two together, it becomes negative 12. And now we can just cancel. So x minus 3 and x minus 3 can go together. We're left with x plus 3 and x plus 4. Now we can sub in the value of x as 3. So when limit x tends to 3, so sorry, that's a 0. Then it should equal to 3 plus 3 over 4 plus, 3 plus 4. And finally, our answer should be 6 over 7. That being said, thank you very much.